So we talked about how the number of groups of 3 of 5 you can have times the number of orders you can put each of the 3 items in each of those groups, finds a total number of orders of 3 items you can have or make from 5 items. But now I'll show you a formula that does that. So this can also be used to find the total number of orders of 3 items you can make or have from 5 items. So you have your 5 items, and then you've chosen 1, so you have 4 left that you could choose from. Then you have 3 left from which you could choose from. So given you are choosing just 3 items, you have 5 times 4 times 3. Now, if you wanted to find out, so if you wanted to find out how many groups of 3 there are in 5, so we know that every group of 3 items rearranged 3 factorial times makes up the total number of orders of 3 things possible out of 5 things. So number of groups of 3 times, so in 5, number of groups of 3 in 5, this is again same problem, we're still doing the same problem, times number of arrangements possible of any group of 3 equals the total number of orders of 3 items you can make in 5 items. So given we know this, if we have figured out the total numbers of 3 items you can make in 5 items, which we did on the other side doing 5 times 4 times 3, then we could find out how many groups of 3 there were. So it's strange because we talked about the definition of what we were doing here. Number of groups of 5 you can have times number of orders you can put each of the 3 items in gives you the total number of orders of 3 you can have in 5. Which we said we could do like this. But it's confusing because I said you have to do this in order to find the number of orders. We can't really do that though. But we can, after finding the number of orders we have, number of orders of 3 things we have in 5 things, we can go back and find how many groups there were of 3 things in 5 things. Because we can plug that number, 5 times 4 times 3, into total number of orders of 3 items you can make of 5 items, and then we can solve for number of groups of 3, because we know also number of arrangements possible of any group, which is 3 factorial. Because that's how we talked about in this above here. So number of orders you can put each of the 3 items in was 3 factorial. So, thank you.